You must be the person that Andrew told me about. Come on in, grab a seat. I've got your coffee here. Now, you're going to need it. So, Andrew told me that you're looking to learn Java, and apparently you've never done any programming before. It's cool. Don't worry. No, seriously, that's good because it means I don't have to sit here and spend the next hour undoing a bunch of bad habits that someone else taught you 6 years ago. You know. So I'm going to assume that you know absolutely nothing about Java, and that's exactly where I want to start. Forget about Spring Boot, forget about databases, forget about REST APIs, forget all about the stuff that people have been talking about with building with Java Online. So today we're just going to sit down and, you know, have a little talk about the language. So let's start with the obvious question. What is Java? So Java is a programming language, but more importantly, it is a way for us to give a computer some instructions so that you write your Java source code. That code becomes compiled into something that we call bytecode, and that bytecode then runs inside of this thing called the Java Virtual Machine, or you'll hear me refer to it as the JVM. Now, that's one of the really interesting things about Java is that your program isn't necessarily compiled directly into instructions for one specific operating system. Instead, the JVM provides that environment for your program, and that's where you get the famous idea of write once, run anywhere. At least, that's the idea. So, Java's been around for decades, but the important part is that Java isn't stuck in the 90s. Modern Java looks very different from Java that your grandfather remembers, or I remember. So let's start with one of the simplest, smallest building blocks of the language. Imagine that you have this little container and say I tell you to put somebody's age in here. And that's basically what a variable is. It is a name that we give to some piece of information that our program needs to remember. So for example, int age 25. We're essentially saying I want a variable that I'm going to call age so that I can refer to it later, and I want it to go into the memory containing the number 25. And we could also have things like string name Mike, or maybe is open true. Maybe we have a coffee shop. And already we're starting to teach the computer about the world that our program is going to be working with. A person's name, their age, whether or not something is open, how many coffees we have left in an inventory. That's programming. And you're taking information, giving it meaning, and giving your program a way to work with it as well. But now we need to make an important distinction because not all variables work in the same way. We have primitives versus objects. Java has primitive types such as int, double, boolean, char. These represent simple values. An int represents an integer. A boolean represents true or false. A char represents a single character. They are fundamental pieces of data. Then we have objects. For example, string name Mike. String is an object type, and this is where Java's memory model starts getting interesting because that variable isn't necessarily holding the entire object directly, it's actually holding a reference to an object. So think about it like this. If I give you a piece of paper with my address on it, that piece of paper isn't my host, it's just telling you where my host is. And that's roughly the idea of a reference. Your variable can point toward an object living somewhere else in memory, and that is where you'll hear programmers talk about the stack and the heap. Now, very simplified, the stack is associated with things like method calls and local variables, whereas the heap is where objects are allocated. So if I write int age 25, the int is a primitive value. But if I write person equals new person, now we've created an object. The person object lives inside of the heap, and the person keyword holds the reference to that object. Now, I want to be careful here because programmers sometimes explain this as primitives live in the stack and objects live in the heap. And that's useful beginner mental model, I suppose, but it's not the complete truth. So the JVM is free to optimize how things are represented. The important concept for you right now is that a primitive represents a value and an object variable represents a reference to an object. That's the distinction I want you to understand. And we'll get much deeper into memory later. But for now, let's make the program actually do something. So imagine we're building our little cafe application and we've got an integer of coffee count equals 10 and we want to know whether we still have coffee available. So we can use what's known as an if statement. So, if coffee count is greater than 0, print out that we still have coffee. Read that almost like English. If the coffee count is greater than 0, do something. We want to give the program an alternative path. If coffee is greater than 0, do this, else do this instead. And now your program can make a decision. That is a huge step because we're no longer just storing information, we're using information to control what the program does. And those conditions can get more interesting. So you can compare values and you can compare conditions with and or. Now, you can check whether something is equal or not equal. And eventually, you'll use modern Java features like a switch to make certain decisions a little bit cleaner. But there's one more thing that you need because making one decision isn't necessarily enough. And what if we had to do something again and again and again? For example, let's try out to see, you know, if let's say our cafe shop had 10 employees, and I don't want to have to write print out this name, print out this name, print out this name, print out this name, print out this name. That kind of gets ridiculous, especially if you become a big company and all of a sudden you have a few hundred. Like, whoa. So we can loop So for example, uh, if we were to look at this code here, we are telling Java, start with I at 0, keep going so long as I is less than 10, and after every iteration, increase that I by 1, and that's a loop. So you can also do things with a while loop when you don't necessarily know how many times that you have to do something. You just have to do it until a condition is false. And eventually, you'll even start using enhanced for loops when you're working with collections. So the important idea is conditions let your program make decisions, loops let your program repetitively work. So now we are starting to have the basic ingredients for an actual program. Uh, but we've still got a problem. We're putting everything into one big pile, and that's where classes come in. So let's say that we want to represent an employee. I could write something like this, and this class is the definition. It is the blueprint. It tells Java an employee has a name and an age. But the class itself isn't the employee yet. It is just a blueprint for how to create one. When we write something like this, even she knows, this is how we create an object. And this distinction is incredibly important because a class describes what something is, and an object is an actual instance of that class. So once you've understood that, object-oriented programming starts becoming much easier to reason about. And then we can add things like methods. How does this object do something? So maybe our employee isn't just storing information. Maybe they actually want to do something like make coffee. So this is where Java really starts to become powerful. We can model our application around things that exist inside of it. So employees, customers, orders, coffee, inventory, accounts, whatever our application needs. Now, I'm also going to introduce you into something that looks terrifying when you're new, and that is generics. Okay, so you may see things like list string, and you'll probably look at this and think, what the hell are those angle brackets? Less than, greater than? Um, don't worry, they're actually there to make your life easier. They are there to tell you that, okay, generics allow us to tell Java what kind of data is supposed to be inside of here. So this is a list of type string. The type is just the generic type. So this is also a list of integers, meaning this gives you type safety. So instead of throwing random objects into collections and hoping everything works out, we tell the compiler what belongs there, and eventually you will learn things like T or type extends number, and something extends this type. And then maybe you'll see something eventually along the lines of something is the super of some type. And yes, those do look ugly, but don't memorize them. Understand that the problem that they solve, that is the pattern that I want you to develop as you learn Java. Do not memorize syntax just because somebody told you to. Understand why it exists. And then that is where I want to jump ahead for a second. And because since we're learning modern Java, all modern and modern Java has some really interesting tools for concurrency. One of those things is called virtual threads. And traditionally, operating system threads have been relatively expensive resources. So if you wanted 1,000 of those tasks running concurrently, then you had to be very careful about how you manage those threads. Modern Java gives us virtual threads. So something like this. And Java can manage lightweight virtual threads for those given tasks. Now, I'm intentionally not going to do a deep dive into concurrency today because if I start going down that and scheduling, synchronization, race conditions, locks, structure, yada yada, we're going to be here till the cafe closes. All right, and that's not what this first meetup is all about. I want you to see where we're going because it isn't just some old language that developers mention in the history books that's been around forever. It's still evolving. And the Java that you're learning today is very different from the Java that I learned 20 years ago. So, what did we actually cover? Um, I started out with what Java was, and then we talked about some variables, some primitive values, objects and references, and the basic idea of stack and heap memory. Now, then we, you know, taught our program how to make decisions with if-else statements. We talked about how to repeat work with loops, and then we introduced classes and objects, and we started talking a little bit about generics and type safety. And of course, I've also gave you a glimpse into the future with Java virtual threads. And honestly, that's enough for today because I don't want you leaving this table with 50 different keywords in your head and absolutely no idea what is going on with them. I want you to understand the foundations, but next time we meet up, if you're going to come back, if I didn't just scare you away, we're going to take these pieces and start talking about something that every serious programmer needs to understand, which is data structures and algorithmic analysis. How do we actually organize this information? How do we find things efficiently? Why is one solution faster than another? And of course, I'll answer the question, what is big O? Uh, that's a conversation for another coffee. So keep your curiosity open, your skills sharp, and that coffee cup full. I'll catch you as we meet up next time.